Bismillahirrahmanirrahim. Okay, now we continue our discussion on the tutorial that I have provide to you all. So we have discussed up to the question number 3. So number 3 is done. Now we skip first number 4. We go direct to number 5 because number 4 here will be take effect on your second test. So we skip it first. We go for number 5 and then we discuss number 4 later. Okay, let's say we have number 5, design a buck converter. Continue with buck. So once you have a question of converter, please again draw. Okay, what to draw? The diagram of the concept. A buck converter, which is to step down. So we are stepping down from the source of 20 volt. We have here Vs of 20 volt. Then with the power output maximum of 12 watts. Then the ripple factor of 0.5%. Then what else we have here? Switching frequency, F switching, 30 kilohertz and 30 kilohertz. What else we have? Duty cycle 0.5. Okay, 0.5. So all assumption that you need is that this converter should operate in CCM. Okay, for this moment we assume that it should be run in CCM. Okay, but what I mentioned to you all, even though being request or not, please one thing is draw the concept, then calculate whatever that still missing here, and whatever that's still missing here, which is, so now we are given D, duty cycle given, so we need to know what is your R value, how much is your resistance value. So R or V is equal to IR, or P is equal to V square over R. So R is equal to V square over P. Okay, but still we have not obtained what is V out now. Okay, so V out is equal to V out over Vs is equal to D. So V out is equal to D times Vs. So 0.5 times V source of 20. So we have here 2 times 5, which is 100 volt. 10 volt, sorry. 10 volt. So this V out is 10 volt. So equal to 10 square over P, which is 12 watt, and 10 volt divided by 12 watt. So how much is our R now? Which is 8.33 ohm. 8.33 ohm. So this is our R. So you have calculate for this you have calculate for V out, you have calculate for R. Then we move to the next step of, so the next step of finding what is the required inductor. So L minimum such that it still operate in CCM. If you refer to our appendix, is equal to 1 minus D times R over 2F. And so 1 minus duty cycle that being provided 0.5 times the R that we have calculated 8.33 divided by 2 multiplied by frequency of 30 kilohertz. So we shall get, so please please write accordingly your steps. So 1 minus 0.5 will be 0.5 times 8.33. So please be helping to write again the steps. Don't just do the bulk calculation, then you get the wrong answer. So you shall get here how much? So it will be 4.165 divided by 60k. Okay, so write the steps so you won't miss your marks at least. So you will get 69.42 micro Henry for your N minimum. Then for normal practice, this value should be increased another 25%. So the L should be 1.25% times 69.42 microhenry, and it will become 86.77 microhenry, which this is the value that you have to buy from the element 14. Not supposed to be element 14 only lah. So you have to acquire from your supplier. Let's say your supplier has only 87 microhenry, so this is the value lah. Or 90 microhenry, so this is value that you have to buy lah. But you cannot buy, or you still can buy 85 like that, but you have to calculate again. Does it still in CCM or not for your skirt letter? Okay, this is the values that should be used for your design, because you have to increase another 25%. Okay, then what else? So what else here? Then you need to see how much is your capacitor, and we need only to calculate for your design the inductor and capacitor. So for capacitor, we have been provided on the, see here, your ripple being provided here, which is 0.5%. 0.5% of ripple. So from the appendix, we have been acknowledged that delta V out, which is the ripple factor, over V out is equal to 1 minus D divided by 8LC F squared. So for C is that you have to shift all the formula. So 8L delta V divided by V times F squared. So 1 minus 0.5 over 8 times your L here. Sorry, this is L1. 86.77 micro times 0.5%. 0.5 divided by 100 times frequency. How much is the frequency of our system? How much is it? 30 kilohertz. So times 30k multiplied by 2. No, power by 2. Okay, solve accordingly. 1 minus 0.5 is 0.5. So 8 times all the values here is how much? Then only you come out with the answer. So it becomes 0.5 divided by 3123.7. So calculate step by step accordingly. So finally you shall have 16 microfarad for your required capacitor. Okay, this is your design output, or the values of the component that you have to provide for the buck motor circuit. So design a buck converter means that you have to calculate these two values, L and C, and L and C. Okay, so in terms of how much the current that flows inside your inductor, so you can calculate, but because you want to know the response in terms of your IL versus time. So when it starts with string, then it will have a ripple. If you zoom this area, it will show you how much in terms of your maximum and minimum. So this is your IL max. This is your IL minimum, and it should be above 0. See, above 0. If it remains here, so this is boundary. If it shoot up, then it go down and up like this, so this is so-called DCM. So this is continuous current mode. This is boundary. This is DCM. So if you need your circuit to work in CCM and CCM, so you have to make sure, or you have to calculate to ensure that your circuit is producing IL minimum at above 0. Above 0. So the issue is that when we reduce the power here, we run at 12 watt, okay. But if you reduce the power down further, so that's why that's where the issues happen. So the current tends to reduce, touching your 0 line. And so we need to confirm at which level it touches the 0 line. So here you can calculate for this power value to see how much is your IL max. But it's not compulsory lah. So the most important is that you have to calculate for L and C. L and C. Okay, that's for number 5. So for number 6, we shall skip first. Number 6 here, we shall skip first because this is more on the analysis of your buck converter, but looking at your current on the diode and the average source current. So this one usually being static, not being any critical what's so called issues. So we skip this one first. So we shall consider another question on another slide. Okay, thank you very much.